This video pertains to pulley problems, much like the one you see here on the left, also known as an at-web machine. And in an upcoming video, I'm going to take a look at a different type of pulley problem, something that looks like this one here, where you have M1 over a pulley like this, and M2 down here suspended over a table. But again, this particular video, we're going to take a look only at the simple pulley system like this. Let's start off with a simple system like this, where you have two masses that are draped over a pulley. And it's pretty obvious that 2m over here on the right is heavier than m over here on the left, and so 2m is going to start to pull down this way, which is going to make m go up this way. Since they're attached by a string, they're both going to have the exact same acceleration. So the direction for the system of the blocks is going to be this way. So both m and 2m are going to have an acceleration in that direction. But what we have to remember here is that gravity always pulls down. So what that means is the block on the right, 2m, is going to be falling at a rate of m2 times g, and the block on the left over here, m, is going to be falling at a rate of m times g. Think of it this way. Let's reorient the blocks in the pulley. Here's your pulley right here in the center. And now we have m2, instead of falling straight down, we have it going over here to the right. And here, m1, instead of having it falling down to the left, we have it moving to the left. So imagine, if you will, a dotted line that goes right down the middle there. Anything to the right of the dotted line, let's say that that's moving in the positive x direction. And anything to the left of the line, let's say that that's moving in the negative x direction. So this means that mass 2 is experiencing a force that's equal to mass 2 times positive g, and the mass 1 has a force on it that is mass 1 times negative g. So let's go back as the problem was drawn previously, and let's put that dotted line right back in here like this. And so now anything over here that's to the right, we'll call that the positive x side, and anything over here that's on the left, we'll call that the negative x side. So that means that this mass over here is falling at m2 times positive g, and this mass over here is falling at m1 times negative g. You got to keep in mind that in both cases, the gravity is acting in the downward direction for both of these objects, right? For this one and for this one. And the role of the pulley right here is it's the direction changer. Anything to the right of the pulley is being pulled in the positive direction. Anything to the left of the pulley is being pulled in the negative direction. So when we sum the forces together, we should be able to figure out the overall net acceleration. So the overall sum of the forces in the x direction, even though it's over a pulley, we're going to call this the total x direction, is equal to the sum of the masses, which would be m plus 2m, times the sum of the accelerations, which is your net acceleration, and that's got to equal m1 times negative g, because it's being pulled in the negative direction, plus m2 times positive g, because it's being pulled in what we've described as the positive direction. So let's do this. Let's move this equation up here for a second, and let's clean it up a little bit so we can solve and see what's going on. The sum of the masses, which is going to be 3m, you see here that you've got 2m plus 1m, that's going to make a total of 3m. The sum of the mass is 3m times the net acceleration is going to be equal to m2 minus m1, and you can factor out a g. See how I did that there? I was able to take m1 and m2 and just put them together here, factor out a g, making m1 negative because it was multiplied by a negative g right there, and that gives us our overall equation. Next, I'm going to replace m2 with its actual value, which is 2m, place that there, and I'm going to replace m1 with its actual value, place that right there. So now when you do the subtraction, 2m minus m, you get m, and now we can solve for a. So when we divide mg by the 3m down here, you can see that the m's are going to cancel right there, and that's going to leave you with a net acceleration that's equal to g over 3. And what's of particular importance to note here is that both m and 2m are going to be going in this direction, which is a positive direction. So your a net is equal to a positive g over 3. We've defined that this direction is positive direction. If m over here was larger than 2m, then what would happen, of course, would be that the mass system would go this direction, and you'd wind up with a negative net acceleration. And finally, one last thing you should really note about problems like this is once you find the net acceleration, you can use it in an equation like v equals v naught plus at. So you can use it in a kinematic equation, or x is equal to v naught t plus 1/2 at squared. And in both cases here, your a is going to be that g divided by 3. Now you might have thought that I left out the tension accidentally in the previous problem, but really I didn't. You see, the tension over here on the left and the tension over here on the right are equal but are opposite to each other. So when you add them up, they wind up canceling each other out. Really, all that you need to worry about is the force of gravity that's acting in the downward direction here and the force of gravity that's acting in the downward direction there. When you add those two forces up, you get the sum of the forces. So what's the trick? Now that we've seen this video on pulley problems, let's take a look at some shortcuts that might help you on the exam. One of the key things to remember here is that the pulley is actually a direction changer, and to the right of the pulley we're going to say that anything that moves in this direction is moving in the positive x direction, and anything to the left of this line, going this way, is going to be moving in the negative x direction. Describing that mathematically would look something like this. The sum of the forces in the x direction, this whole thing here is the x direction, is equal to 2m, this mass here, times positive g, since it's acting in the positive x direction, plus the other mass, acting negative g, it's going in the other direction, and that has to equal the sum of the two masses times their net acceleration. If we factor out the g, it'll look something like this. And then if we want to isolate a net by itself, we can divide the left side of the equation by 2m plus m and keep a net by itself, and it looks something like this. A net would be equal to 2m minus m, all times the quantity g, divided by 2m plus m. So let me give you a formula that will work in pretty much any situation here. Let's first name these blocks. The block on the left, let's call that block M1, and let's call the block on the right M2. And now our overall equation would look something like this. A net, or the net system of the blocks, is going to equal M2 minus M1 times the quantity g, all divided by M2 plus M1. This equation right here will work in every situation. Very simply, it's just the difference between the two blocks times g divided by the sum of the two blocks. So notice that I made M1 the negative one. Over here on this side we call this the negative x direction, and M2 I made the positive one. Over here we've called that one the positive direction. Consider for a moment that you were going to cut the string right here, for example, and cut M2 loose from M1. Basically, that cuts M1 out of the equation, and you'll notice that your A net winds up being G, or positive G. M2 would fall in the positive G direction. Or consider you cut the system right here, and you cut M2 out of the equation. Now your net acceleration is going to be negative G, because now you've got a negative M1 divided by positive M1 on the bottom. That's going to give you a negative 1. Negative 1 times G is negative G. Now, of course, the whole reason for doing this is so that you can use a net in a kinematic equation in something like v equals v naught plus at, or x is equal to v naught t plus 1/2 at squared. In both of these cases, that acceleration there, that's your a net.